this thing on? I'm just kidding. All right, so what's up? So this video is goes along with the cell transport video. We're going to focus on osmosis. Um, Osmosis works just like diffusion, right? So high areas of water go to low areas of water, or low concentrations of water. Now, if possible, osmosis is not going to happen, right? So ideally, diffusion of the solutes, facilitated diffusion with a channel protein is going to happen. But if these things are too big, if there's no way for them to get in and out of the cell, then nature is not going to allow the environments to remain unbalanced. They got to find some way to get to equilibrium. So if there's no way to move the solutes, to allow the solutes to flow, then we're going to have water moving. And this is osmosis. So it's kind of like the last resort, theoretically. Right. So that's what we're going to talk about today, as osmosis and how does water flow. It flows much in the same way that the solutes flow. All right, we're not going to get into proteins and permeability and cell membranes and all that, but high concentration water to low concentration water. We're going to use three words to describe the solutions or the solvents, right? So these words will be, they'll end in tonic. So our prefixes is hypo, hyper, and iso. So that'd be hypotonic, hypertonic, isotonic. Tonic is like, a solution remedy, medical thing is what, the definition of it is. So just think of tonic as solution, right? So it's either going to have a higher content of water in the solution, it's going to have a lower content of water in the solution, or it's going to have the same amount of content of water in the solution. And that's what we're going to mean by this. So looking at the words, the prefix, hypo, hyper, iso. People have heard of being hyperactive, right? The term hyperactive means that you are overactive or you are more active than normal. So hyper means more, right? So if you are hypertonic, that means that there is a higher percentage of water in this solution. So if you're hypo meaning like under or beneath or less, right? If you're hypotonic, you have less or under the amount of water in the solution. If you're iso means same. So I'm going to just kind of throw some numbers out here, right? This is a cell, right? This is the, if we're talking about things in the cell, right? We've got our nucleus, our cell. We're talking about intracellular. This is the intracellular area, and things outside of the cell are going to be the extracellular environment. So let's just say I'm going to throw some numbers out here for the solution inside of the cell. Let's say we got, 92% water, 76% water, and 84% water. So that is the percent water of the solution inside of the cell. Now, let's throw some numbers out here for the extracellular environment. Let's go, we'll say out here is 96% water. Over here, we'll say 71% water. And down here, we'll say 84% water. So, what you should do first is think about the percent of the solutes too. So, together they're going to make 100% of the solution. So, if I do that, if I know that 92% of the solution inside of the cell is water, that means 8% must be solute. Down here, if 96% of the solution is water, that means 4% must be the solute. Same thing here, if we got 76, all right, that means we're going to be 24% solute. For 71, that means we're going to be 29% solute. 84 and 84. So both of these have the same percentage of water. So both of those are going to have 16% solute. So it's just nice to get all the information you can out there about something. Don't just leave the solutes out. I know we're focusing on water. This is osmosis. Okay, but having both numbers there might help you be useful. More information is not a bad thing. So, looking at this. Now, if we describe this solution, right, I have a higher percent of water in here. Oh, sorry. I have a lower percent of water in here, higher percent out here, right? So, more, okay, so the outside environment here is hypertonic, okay? And the inside environment here has less water, so it is hypotonic. Moving down over here. I have less water outside. I have more water inside. So my solution outside the cell in the extracellular environment is hypotonic. And inside of the cell is hypertonic. Down here, we are the same. There's the same amount in as there is out. So this is isotonic. This down here is also isotonic. A lot of the problems with confusion is that, students or people only name one. Like we'll only name this solution out here as hypotonic or hypertonic. Name them both. Name the inside of the cell or the conditions of the solution in the cell and outside. Right? So there's no confusion. You know this out here is hypertonic and here's hypo. Hyper means more, hypo means less. Iso, same both ways. Because then you'll know, right? It's easy to figure out what's going to happen next. So if we have hypo in here and hyper out there, we have less water inside the cell, more water outside the cell. Water is going to move via osmosis into the cell from hyper to hypo. Right? Same thing over here. If we know where hyper and hypo is, from hyper to hypo, right? Which can mean from inside the cell to out, just as well as it means from outside to the in, right? So identify where both of them are. More water goes to less water. Down here, iso. All right, that's the same. There's not going to be any osmosis. Well, equilibrium and balance in nature is not like steel. It's not dead. So you're still going to have some water moving in, some water moving out via osmosis. All right. That's osmosis. That's the movement of water from high to low. We're done.